Eric Burgess here, and we have been given a sequence, and they want us to rewrite this sequence using n. And remember that n starts at 1 and continues on in integer fashion forever. So we want to use this sequence and rewrite it using n. So let's see if we can't do this. So this sequence looks a little strange at first. 1, 0, negative 1, 0, 1, 0, negative 1, 0. It just repeats like this. So how will we do this? Well, first we notice the sequence itself is repeating. And this screams trigonometric functions. In fact, this looks just like a unit circle, doesn't it? If we were to look at a unit circle, right? We start out 1 is up at the top, and then we go to 0, then to negative 1, then to 0. So we say, what function has this property? And since we want to start at 1, the property, the function I'm thinking of, you could do this with different ones, but I'm thinking of sine. You could do this with cosine. It'd be a little more convoluted, I think. But since we want to start with 1, I think sine would be the place to go. So here we're going to write in a sine. And to start at the top of sine, you have to be at an angle of pi over 2, right? Now, the last little bit is, okay, well, sine of pi over 2, how many pi over 2s do we want? Well, we want one of them. And so that will give us the 1. When we have 2 pi over 2s, we'll be at 0, right? So we're moving around the unit circle, right? This is 1 pi over 2. Then we're at 2 pi's over 2, 3 pi's over 2, 4 pi's over 2, 5 pi's over 2, 6, 7, 8, 9. And you can see we can go around forever. And this would produce that sequence. So it's really n pi's over 2. Because we'd start at 1, and that would give us our first pi over 2, then 2 pi's over 2, then 3 pi over 2. And around and around and around we go. So this one, we could have sine. Now we can also write this in terms of cosine. However, cosine is going to look a little bit different because it starts in a different place. So if we were to write cosine of pi over 2, you could actually just use a trig identity if you want, but let's just go through the thought process. So let's think about it. If we're at sine, sine of pi over 2 is going to be up here. But cosine of pi over 2 is going to put us right here. This is going to produce 0 for cosine. And we don't want cosine to produce 0. We want cosine to produce 1. That's over here. So what we need to do is we actually need to do, we need to shift it back this way. So before, right, if sine would start up here for pi over 2, but cosine is going to give us a 0. We want to give us a 1. So we actually want to do n, and we want to go back a pi over 2. So we're going to do n minus 1. So this is going, right, this one would evaluate to 1 pi over 2. This one's going to evaluate to 0, and cosine of 0 degrees, so this is a little confusing because I have a 0 here. But if we had 0 degrees, right, that would just be this line, and that's going to give us 1. So this is what it would look like if you chose to use cosine instead. So you could use either one. There's probably other ways of writing this solution. I think sine's the easiest one. It occurs to me first, but you could use cosine as well. If you have any questions or alternate solutions, feel free to drop them in the comments. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.